The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, welcome to SITAC webinar series. My name is Rakesh Malakar. I am one of the core organizer members of the SITAC. We have a very exciting presentation today in security architecture, and we are joined by our special guest, Terumi Laskowski. She teaches various security classes in different organizations, and I have got opportunity to take a few security related classes with her, and I have thoroughly enjoyed her classes. Before we start the presentation, a few housekeeping details. If you have any question, please type in the question box, and during the presentation, Terumi will pause for questions and I'll read the questions to her. Terumi, the floor is yours.
Great. Hey, thank you very much for that very nice introduction. And hi, everyone. I'm so glad that I have this opportunity to share some of my knowledge relating to IT security. You've probably seen in my profile that I've been in security for a long time. And I've touched on various phases of security, starting from requirements gathering all the way to operations and maintenance. And that also includes, of course, development and design as well. So today, our focus is on how to build security into your solution. And building in security isn't just about architecture, but architecture is one of the most important parts as well. So during this class, I will talk about what is security and who is responsible for building in security, and then what is your role as an architect, and what are some tools available to you so that when you're designing your application or your solution, that you know that you are doing the right thing by security. Okay, so that's what I have planned for you. And the presentation will go for a little over an hour, and I know this is a 90-minute presentation, so I have some time available for questioning as well. So please go ahead and type in your questions, and Rakesh will go ahead and let me know what those things are. All right, so getting started. The agenda for you today is let's be clear about what security is when we're talking about security. Okay, because there are a lot of things, and security may mean a lot of things to different people.
Terumi,
so what does it mean? Yes.
Sorry to bother you. Can
you? Yeah, right. Got it. Here we go.
All right, we can see the agenda.
All right. Yeah, sorry about that.
No problem.
So here's the agenda. The security, let's go ahead and define security. That's basically to get our baseline on our definitions so that we're talking about the same thing when we're talking about security. And then let's talk about what is this thing about building security in, okay? And what does that mean, and who builds it in? And it's not just one group of people. So let's go ahead and understand that so that you can understand your responsibility within the entire process. And then what are the concepts and tools available for you as a security designer? Okay? And then I do have some references in the end. All right. So let's go ahead and talk about, is security important? And I think we'll have, everybody will probably say, they probably won't say security is not important, but if I'm going to show you this site that I have presented for you. This is a site called Information is Beautiful, and so let me go ahead and show you that site right now. And I think it's going to come up. So this is their visualization of the world's biggest data breaches and hacks. And they update this quite a bit. So I'm not sure if it's really up to the minute, but they do have some incidences on 2019 already. Okay? And you have 2019, 2018, 2016. And the size of the boxes reveals how much data was breached. Now, security incidences aren't always about data breaches. There are many other things. People can stop your system, people can take over your system, and also people can leak information and steal information. So I believe here it's mostly about data leakage. But data leakage is a pretty big deal because companies are sued for that if they lose data, and they damage their brand if major leakage occurs. So this is basically what happens, and you can see that if security is indeed important to corporations, why do we keep on having all these security incidences, right? So if people are putting efforts into stopping security because it's important to them, why do we keep on having these things repeatedly over and over? And this data goes all the way back to, well, let's see, 2010, 2008, right? And I've been in this business way before that. And the fact that I was gainfully employed as a security consultant, that means that there were plenty of incidences even back then too. So then why does it perpetuate? Okay, and I think by the end of the presentation, you'll get some ideas as to why it is that it's very, very hard for corporations to prevent these types of hacks. And you as an architect will go a long way in helping these corporations in stopping, as a minimum, reducing the risk or reducing the damage of these types of hacks. All right, so let's go ahead and move on. So is security important? I hope so. Right? And is there something that you can do something about? Right? And the answer is yes. Right? There is something that you can do. You as an architect, okay, can do. So let's go ahead and dive into some of the areas that you are able to help. So let's talk about, briefly, definition of security. Okay? And very simply, security is about protection of IT resources. Obviously, we're talking about IT security. Okay? So IT resources. But the question then is, what do we mean by protection? Okay? And what do we mean by IT resources? So let's go ahead and examine that one by one. So let's first talk about then, what are IT resources? Okay. And I'm going to practice using this whiteboard here. All right, so here we go. Now, IT resources, very simply, is everything that surrounds data, right? The data that you have to protect. And understand that when you go to corporations, not all data has the same priority. Some data is more important than others. And so let's go ahead and put in the data. Okay. And be specific that it's the data that your system will handle that is of any value where the company wants to protect. Okay. And the reason why not all data is in the scope is because basically money and effort. Right? Because if you're trying to gather security requirements for every single piece of data, we say in security, don't spend $10 to protect $1 worth of asset. Right? So if it's $100 worth of asset, then you definitely will spend $10. Right? So make sure that that's what you're talking about. But it's not just data anymore, is it? Because data wants to be processed. Right? That's basically how data becomes useful. So this is a rendition of PC. Okay, and so anything that processes data will also need to be protected. Okay, and that includes, of course, application, and your solutions will be part of that. And data also wants to be stored. Right, so I have a little hard disk here, and store it. Now, any of these things could be on-premise, that is locally available on the physical devices, or it could also be in the cloud. Right? So it could be virtual processes and virtual storage. It really doesn't matter. And of course, so then let me just put store here. And data wants to be transmitted. So here we go. This is something like a network. The data transmits it. There we go, transmit. So it must be protected while en route to somewhere. And when it reaches its destination, there you go, that's the destination, they usually are displayed, right? So we display it, and the display could be anything from display system or perhaps a printer, right? Anything that displays it. And in fact, anything that a person can see is part of the display. And when you display it, the display is also done in a, let's say, a facility, something like a data center. Here we go, data center. And data center, I'm sorry if you hear some noise, I do apologize for that. So we have data centers. And when we're talking about security of data centers, because it houses everything that displays your data, is basically a physical security, right? So this may not be in your design, but it's still part of information security. Okay, so these things, the data, what processes data, what stores data, what transmits data, and what displays data, and everyone who comes in contact with data must also be protected, right? And this is the entire scope of information security. Okay, and I hope that's clear. All right, moving on. Oh, sorry, went a little far. Okay, so that's IT resources. So the next then, the definition of protect, right? So when we talk about protecting something, what do we really mean? Because if you're going to be designing a system, you need to know specifically what it means to protect data and all the resources. So let's go ahead and talk about that, right? We'll first talk about the concept of CIA. No, it's not that organization that you may heard of on TV, right? It means something else in security. We'll also talk about something called authenticity of source, and then finally we'll talk about non-repudiation. Okay, so there's actually, let me see, 1, 2, 3, 4, 5 concepts that we commonly use and refer to when we're talking about security. Okay, so let's go ahead and talk a little bit about the CIA. All right, so let me go ahead and open up a brand new sheet here. Okay. All right, CIA. It stands for confidentiality, integrity, and availability. All right, so confidentiality, I think you probably can guess what that is to keep secret things secret, right? And only reveal or give access to those who are authorized to see it or handle it. Everybody else who sees the data could be possibly a cause for data leakage. So if you have broken confidentiality, you have data leakage. Integrity is about tampering or disabling tampering. So tampering means to change information without proper permission. So for example, let's say you go to an online e-commerce site and you click on the product and the product, it says it's $50, whatever that is, right? What if you can actually manipulate the HTML, okay, in that page and change the $50 to $5, and then you submit that, and the website returns and say, thank you very much for your purchase. We've just charged your credit card with $5, right? That has actually happened in one of my pen testing customers, and the reason why that was possible is because of not really the fault of the designer, but because of the poor coding practices by the developer, right? So the coder. So I hope that gives you a pretty good example of what an integrity flaw is. So when you broken integrity, you can't really prove if the data is a authentic or legitimate data. Somebody has tampered with it. Availability is about access to the system. So systems are usually designed with certain promise for a response time, certain performance level, right? That's how you design your solution. And if it goes over that, that is, if you can't really keep up with that performance, then it could possibly be a security flaw. Right? Now, you probably noticed some websites that are slow, and I'm sure they didn't plan that to be that slow. And maybe there's delay due to congestion. It could be delay due to many other factors, which has nothing to do with security. But a hacker could come in and bring down your server, and now the system is unavailable. Or a hacker could come in and create a process in your server to busy up your CPU. Now your server is way slow, and it breaks perhaps an agreement, service level agreement that you have with the actual customer. In that case, that would be a security flaw. Right? So availability is in the gray. Just because it's slow, that doesn't mean that it's a security flaw. Just because something goes down, let's say from somebody just kicking the power cord or something, right? Or spilling a cup of coffee on top of a server or something, and it shorts out the server. It's not necessarily a security flaw, right? So just realize, though, that if it's caused by malicious or perhaps by human error and the system goes down, it could be considered a security flaw. Okay. So that's the CIA, confidentiality, integrity, and availability. And usually, when we're protecting something, we're protecting these three things. Are there others? Yes, there are a couple more others, right? I mentioned about the authenticity of source and about non-repudiation. But compared to the first C and I and A, the effort that you have to put in to design to make sure that these things don't happen is way different. That is, you'll put a lot of effort in CIA, because that is majority of protection that the system needs. Okay, and just kind of do a check on that and make sure that what I'm saying is true. Think about any incidents that you've heard about which you would consider a security incident, right? Data leakage or anything that you've seen so far on the news or on your blog or whatever, and see if you can actually recall anything that had nothing to do with confidentiality, integrity, or availability. That is, can you think of some event that happened, had nothing to do with data leakage, or someone tampering with the system, or system becoming unavailable due to a hacker's efforts? Right? So when you start thinking about that, and if you come up with something, great. Okay, but usually it's kind of hard. A lot of the things that we hear on the news are related to CIA, right? And mainly because these are the main targets, right, of the hacker. So the next thing then is there are two other minor items that we'll talk about. One is authenticity of source. Okay, so the authenticity of source is where you ask yourself, the person on the other side of this digital platform, the person who is claiming to be someone or something, are they authentic? That is it true? Are they lying? Right? Are they impersonating? Are they spoofing? Right? So these are all terminologies that's related to the questions of authenticity. And when we say authenticity of source, whatever the information flow, that flow began at the source, and you're questioning if that source is authentic. Now, I'm sure some of you have, most of you perhaps have traveled, perhaps on the plane, and before you can go on board the plane, you have to show your ID, right? And in my case, I'll probably have like a driver's license or perhaps a passport, and whenever the person at the customer, when they're checking that, they'll check to make sure that that documentation you have is something that they trust, right? So if it's issued by the U.S. government, great, right? If it's issued by, let's say, I actually have a driver's license from Japan. Now, if I were to show that to a U.S. customs, they'll say, what in the world is this thing, right? Because they don't know where it came from, who authorized that to be issued to me. But if they trust the source of the issuer, such as the State Department for passports and state motor vehicles, let's say for driver's license, they'll usually trust that. And the next thing is they'll probably kind of look at the picture and make sure that it hasn't been tampered with, right? And they'll make sure that that picture matches you, right? So that is checking for integrity, okay? So what is the equivalent then of that type of identification on the digital world? Right? And there could be many sources, but there's one source that you can actually bring to court and say this is authentic because I have this ID issued by someone, and that ID is called digital certificate. Right? So the authenticity source is usually acquired using the digital certificate. And the digital certificate has other components other than just who you are. But we won't go into that today. If you're interested in that, you should actually check out encryption. Okay, specifically something called the symmetric encryption and asymmetric encryption. Okay, but the digital certificate must be issued by someone that everyone trusts. Right? So there are third-party vendors. The example that I have is companies like VeriSign. Let me see, Komodo, and there are a bunch of them, right? That you pay money for, and then they will authenticate you, and they'll issue you a digital certificate. Okay, so the next one is something called non-repudiation. So non-repudiation is a concept where you cannot say, I didn't do it. Right? So let's say that I purchased something from the online store. Okay, like I order maybe 10 books. And let's say from Amazon, and Amazon sends me all the 10 books that I ordered, right? But later on, I reverse my charges on my credit card, and when Amazon contacts me and say, hey, what happened? You got your books. I know that you received it. Why are you reversing your charges? I'll say, well, it's because I didn't order them. I didn't order them, and you just sent it to me. So why should I pay for it? Okay, but on the surface, Amazon will probably say, but you logged in and you purchased and you used your credit card to purchase it. It was you who logged in, right? They said we have a record of your logging in, and what I could say is that's not me. Someone must have logged in as me, and how can you, Amazon, prove that it was truly me? Okay, so that is repudiation, right? So I'm repudiating the fact that Amazon's saying that I purchased something, and I'm saying no to it. Now, it's very possible that indeed there was some kind of an issue, and that indeed I did not purchase them, and Amazon just sent them. Maybe someone hacked into the system and spent the money and just sent me the books, right, just to harass me. Who knows? Or it could have been just me buying those books. I just didn't want to pay for them, right? So that would be something like a shoplifting. Okay, so for some companies, this is just a cost of doing business, and they won't even follow through with it. They say, okay, fine, right? But if I keep on doing that and constantly buying something and not paying something, then they may stop me from using that store eventually. Okay, but for a small to medium-sized companies, if people constantly do this kind of stuff, they could drive them to bankruptcy. Right? Some companies, small companies like small stores, have gone out of business due to excessive shoplifting, right? For example. So this is a digital version of shoplifting. So how do you then, as a store owner, stop this from happening? Well, the way to stop this from happening is, one, you have to have authenticity of source, right? That thing that we just talked about. You have to make sure that whoever logged in to purchase was indeed that person, like me, like Terumi, right? And then you have to also make sure that whatever I said I order hasn't been modified. So if I truly purchased 10 books, but if I claim that I ordered 1 book, let's say, well, there's a difference between what Amazon sees, 10 books, and what I see, 1 book, right? So what happened? So that's we're talking about integrity, and we talked about that as part of confidentiality, integrity, and availability. So non-repudiation is actually a combination of authenticity of source and integrity. Okay, so it's a combination. But this is also an important concept, right? So somebody's stealing, right, of books and such. So there you go. So when we're protecting the IT resources, the protection, what we mean by that is that we need to protect confidentiality, integrity, availability, and authenticity of source and non-repudiation. There are a bunch more stuff, right? But the thing is, I mean, it's endless. But if you get these, at least at CIA, you'll probably get like 80% of all the problems. So in your design, you have to consider the CIA first, and then look into authenticity source and non-repudiation. So we'll talk about how you would look into these things, but just kind of keep these in mind, that this is what security professionals are talking about when they say protection of IT resources. Okay, so there you go. So we have the protect, CIA, authenticity of source, and non-repudiation. Any questions so far?
No questions.
Okay, sounds good. Either I'm very clear or everybody's asleep.
I think you're very clear.
All right, so let's go. Let's move forward. So then, how do we protect it? Right? That's important. I mean, just knowing how people are robbed or how people are hacked is not going to help you creating a secure system. You have to know how to protect it. And when we're protecting, the term that we use is called controls. So if people are talking about security controls, these are the measures that you take to reduce the risk of a particular thing from being hacked or from being damaged, right? The CIA that we talked about. So let's kind of take a look at this in a pictorial format. Just go ahead and open up another slide. Okay, so in considering these controls, right? Let's go ahead and kind of take a look at what's happening, right? When people are trying to break confidentiality, integrity, availability. Basically, sorry about that. Basically, here we go. You must have an IT resource in mind, right? So let's say it's an application. So let's say this is a server, right, with your application inside or your solution inside. And in order for any type of attack to happen and succeed, there must be a weakness, right, or weaknesses. So let me just go ahead and say these are vulnerabilities. Vulnerabilities, right? So vulnerability means weakness. Okay. By the way, vulnerability doesn't necessarily mean security holes. Let me see. Bugs. Okay, it doesn't necessarily mean bugs, right? Or miscoding. It could be missing some kind of protection, right? Maybe things are too exposed. And that's something that you have to think about when you're designing these types of systems. Okay, you're basically designing in mitigations. Okay, and the definition of mitigation is ways that you can reduce risk. So let's kind of be clear. Risk, right? What risk is the risk is the impact. Sorry. There we go. Impact of an attack. Okay? I mean, the thing, whatever it is being attacked, could be destroyed down to the ground, but if it's worth nothing, then there's really no impact. Okay? So you have to look at the thing and say, well, what is the impact to me? Am I going to lose money over this? Am I going to lose reputation over this? Am I going to lose anything else over this, right? And then you would start to prioritize based on risk. Okay? So the vulnerability then is something, it's a weakness that has certain impact to your organization. Then you must also have something that wants to attack it, right? So there it is. There's the attacker, okay? And this is usually called the threat agent. Okay, and the threat agent is going to attack the vulnerability, right? And there are, the way that the threat agent actually attacks is usually called the exploit. There are exploit tools, exploit methodologies, exploit processes. So, but in general, it's an exploit that meets the requirement to take advantage of the vulnerability. And there are many, many vulnerabilities, right? So that means there are many exploits available as well. And in order for this to happen, though, this is not enough, right? There must be, right? Here it is. It's like a little hole here, okay? And that is an exposure. So the vulnerability must be exposed to the threat agent in order for it to be exploited. Okay? And the exposure and the contact to the vulnerability does not have to be a direct one. It could be an indirect one, right? So what I mean by indirect is, let's say you have a portal site, and you have the front end and the back end. So the front end is your portal application. The back end is a database that has everyone's data inside it. Your database could be attacked indirectly via the front end for your portal. So if you have a vulnerability in your front end portal, the attacker can attack the database through your front end portal, right? But still, it's exposed. Okay? It's not a direct exposure, but it's an indirect exposure. Okay? And you take this whole thing, right? So from the threat agent all the way up to the vulnerabilities here, and that will be considered the attack. And sometimes they'll call that attack vector. Okay? So we got into this theme as we're talking about, well, how do you stop it? Or how do you reduce the risk of this thing? Okay? And that's the, I mentioned that it's control. So what is control? Control is something that you put in here to stop the threat agent from being able to touch the vulnerabilities. You can do that in several ways. You can get rid of the vulnerabilities, right? You could get rid of them. But ask yourself, right? How would you ever know that you have no more vulnerabilities in your system? Right? You say, can you say with confidence that I have no vulnerabilities? Right? So I think we all know that we can't really prove a negative, right? So that means even though you've done your best to get rid of all the vulnerabilities as far as you don't know what you don't know. So there may be vulnerabilities in there that you actually missed. Or maybe a new vulnerability may be discovered tomorrow. Okay, so because of that, getting rid of vulnerabilities is not going to be the answer, right? But it will go a long way in reducing the attack and the impact, because it goes a long way in reducing easy to find vulnerabilities, right? So because if you're doing a good job of having a large list of possible vulnerabilities and you're designing, let's say, designing those things away, or putting some sort of a protection for those vulnerabilities, then it's going to be harder for the threat agent to access anything else other than that, right? It just makes it hard. But understand that from our perspective, you can never say that we have no more vulnerabilities, right? So that means we have to be consistent, constantly vigilant about vulnerabilities on our system. But there's another thing, right? Perhaps you could get rid of the threat, right? It's like, okay, we got the threat agent, it's that person, or it's that application, or it's that organization. Well, as a corporate citizen, you can't really go after the threat, okay? You have to kind of leave that to the police and the authorities, right? Now, are there offensive rather than a defensive security? Of course, right? It's yes. You probably heard of something called cyber war. Well, cyber war is done at the government level, hopefully, not at the individual level. So from that perspective, we're just assuming that you are a corporate citizen. In that case, you probably should not be going after the threat, right? So if someone is spamming you to death and you know who it is, you cannot spam them back. Right? It's basically that, right? Leave it to the authorities. So that means we can't really go after the threat agent. So what else can we do? We could try to reduce as much as possible the exposure of your vulnerability to the threat. And whatever you do to reduce the exposure is control. Okay? And so these are controls, right? Like firewall is a great example. Putting a firewall in will attempt to reduce the exposure of an entire server, right? To, let's say, to a specific service or port. So that reduces the rest of the server from being attacked or becoming a target of the attack. Or you could try to come up with a redundant systems so that if one system goes down, right, you can go and switch right over transparently to the other server. That's also control. So there are many forms of control that you can possibly put in, right? And there are controls that you can design in. And basically that's what people are asking you to do, is to figure out what are all the possible ways that this system could become vulnerable, and then try to think ahead and design features in the system where you're putting in controls. Right? It's as really as simple as that. Well, let's see here. And I want to kind of talk a little bit more about controls. There are 3 different types of controls. And let's see if I can get this. So controls. And only one of this is probably of the interest to you, but let me go ahead and introduce all 3. One is called the administrative control. I'll just put admin control, okay? And I'll explain that. Second one is a logical control. Sometimes it's called technical control. And the third one is the physical control. And I would imagine the one that you'll be most becoming familiar with is the logical technical control. But admin control is, they're like policies, right? So let's say you want to have a very strong password for all the systems, and you want to make sure that everyone sets a very strong, difficult password. You could put in a policy where people have to read and accept and say, okay, you receive training based on this policy, which states that everyone who works here must have a very strong password set. Okay? But the problem with administrative control is that how do you know that that is going to actually cause people to create strong passwords? Right? It's very hard to measure and create a causal relationship between the policy and the actual behavior. You can have a real stiff penalty, and that may do it. Right? It says, if I catch you not putting in strong password, you're going to be fired, right? Something like that. Very strong penalty. But in general, administrative controls are very hard to monitor its effectiveness. But now let's move on to the logical technical control. If you actually really, really want people to have very strong password, then you can actually embed control into your solution, either in a software solution or the hardware solution. So for password, one example would be, let's say, Active Directory. And in Active Directory, there's such a thing called security policy that's downloaded every time a person logs in and enforces that policy on their terminal. So in that security policy, you could say, all right, difficult passwords, 15 characters or more, all the combinations of upper and lowercase with special characters and numbers and alphabets, right, alphanumeric. Then when someone tries to create a very simple password, it will deny them from doing that. So it's going to force the point. Okay, so that is a logical technical control. Now that one is much easier to measure. I hope you can see that. Okay, and those are the type of controls that you must start to think about and design into your systems. Okay, now how are they related to admin control? Administrative control informs everyone and raises awareness that they must do it. Okay, so now everyone knows. And then on top of that, there's a logical technical control that is going to force them to do it. Right? So that's the best combination. You don't want to all of a sudden put in the security that people think that it's going to be very inconvenient. Right? So without having a statement that says, why are you doing it? And then put in a measure that actually forces that effort, then that's a much more ecological, right? People understand the reason why, and they will tolerate the inconvenience of such things. By the way, a lot of people think that security is inconvenient and tedious, because think about it, right? If you know what a multi-factor authentication is, every time you log in, you have to put in your username, password, and then maybe a token. On top of that, you may have to be asked for a biometric. That's pretty inconvenient. Why not? Why can't I just go in with username and password? Because that's considered insecure, right? By putting in multi-layers of security, it may become tedious, but it becomes more secure, right? So people have to want to do it, okay? And last but not least, there's physical controls. You could put in fences, you could put in, cameras, you could put in guards, you could put in dogs, all that stuff. They're all considered physical controls. So 3 categories of controls, and the one that you are asked to do is number 2, logical technical controls. All right, any questions on controls?
there is one question. Just a second.
Okay, sure.
So this is a question from Wang, and he said, if he or she, sorry, if we ask user to verify a code sent to his phone, what type of controls it is?
Code sent to the form.
Sent to a phone. So probably for the multi-factor authentication.
Right, token. And okay, so those are pretty prevalent. And the question is, how do you know what?
What type of control it is out of
Okay, got it. All right. So that's that is actually access control, right? So in the broad scheme of things, that is part of the access control. And the access control has 4 elements to it, right? So that's a good question. And I was going to cover this anyway, so let me cover it now. Okay. And thank you for that question, Wang. So let me go ahead and answer that, and you tell me if that answers your question. So hang on here. Let me go ahead and do that right now. All right. So now that we talked about control, and let me get the white in here. So we talked about control. One of the very, very effective control is called access control. Okay, but just realize that it's just one type of control amongst many, right? But some controls are more powerful than others, and access control, hands down, is very, very important. So access control then, it comprises of 4 factors. One, let me see, AAA, right? IAAA. So I is identity. A is authentication. And the A is authorization. And the last A is accounting. Right? These things are done in the order. So, whenever you log into a system, it asks you for ID, right? And identification could be something that's related to your name, right? Just kind of imagine all the systems that you log into and what is the ID that you put in, right? Probably has something very close to like your email address, your name, or something similar to that. What I'm trying to get at is it's not really hard to guess, right? So if someone knows your name, your company, they could probably try to guess what your username might be for a particular system. Okay? And I'll get to the question. It's actually on the next discussion. But the identity, can you imagine identity being something like strong as a password, where you have like a random identity? Right? Like random identity. You go to a random, on-site online feature and say, create for me a random ID, right? You imagine doing that. And you probably can't imagine it, right? Because don't we now have a hard time enough memorizing all the difficult passwords? And if we start putting in random ID, what would happen, right? People would just put in their ID and the password on a little Post-it note and post it right by their PC, right? That's basically what's going to happen. But why am I talking about random ID? Think about it. If a hacker cannot figure out your ID, can they even try to attack your account, right? So they need to know your ID. They need to know your name in order for them to attack the actual account, your account, to do anything at all, right? So it may not be realistic, but I teach something called the cloud security. So for cloud system, this is actually very much a best practice. That is, if you have a very, very important account that manages entire systems for entire company, then you want that what's called a root account, which has a administrative control to do anything they want, including deleting the entire account. You want to make sure that the identity is random. Okay. So that now going to authentication. Authentication is about asking for evidence that the identity that you mentioned is truly you are who you say you are, right? So they'll say, hey, show me proof. Okay. So in this case, these types of evidence is called factor, right? Or factors of authentication. And there are 3 factors, 1, 2, and 3. Okay. The first one is what you know and what you have and who you are. Okay, so the first factor you know is something like a password. It's something that you know, or your secret, information, something that you know. Something that you have is a token, just like what Wang asked for. It's your phone, okay? And the organization sends you a message to your phone, and you have to, feed that information back into the website to prove that you just received that. And hopefully that phone number is your phone number, and only you have access to it, okay? And to just complete the thought, number 3R is biometrics. So if you have to, scan your retina, scan your iris, punch in your fingerprint or your palm print, whatever, that's number 3 factor. And what we're saying these days is that you have to have combination of more than one of these things, right? So put in your ID, put in your password, and also send a token to your phone, right? So that's a combination of multiple factors. And this, as using multiple factor, is called MFA, right? Multi-factor authentication. It just makes it much stronger. So to answer your question in a long way, is that someone sending a code to your phone is a type of access control, which is part of the authentication process, and is actually a type 2 factor, okay, authentication. Did that answer your question?
Yeah, Wang said yes. Thank you.
Oh, okay, good. Probably more than what you expected, right? but it's nice to kind of systematically know what it is that you're doing, right?
Absolutely.
And that was a very good question.
Absolutely.
Yes.
Thank you
very much for that. Yeah. And just to complete the thought of this, the slide that I have here, authorization then is once the system is comfortable enough to say, okay, you are who you say you are, based on the evidence that you have provided, then what can you do in the system, right? What are the permissions that you have? And once again, this is actually a design factor. You have to say who can do what, right? And usually the who can do what question is using a couple of models. One is called RBAC, and the other one is called the ABAC. I will quickly cover what RBAC and ABAC is. So RBAC is short for role-based access control, right? Role-based access control. And so when you're designing your system, basically what you're doing is you are identifying, hang on here, you're identifying what is being accessed, right? So let's say you have something that's being accessed, and this is called an object. And then you have to identify what is doing the accessing. It could be a person, it could be an application, and this is called a subject. And the subject will access the object. Okay? But if you just allow that to happen, there's no control available there, right? There's no control there. So normally you would put a control that says, who are you and what can you do, right? So there are a couple of ways of defining this type of control. And in a role-based access control, objects will have attached to it different types of permission based on, let's say, job roles, right? So if you're admin, it says if you're admin, you could read, write, and execute me, right? And if you are a guest, you can only you can only read me, right? Let's say. And then the subject will also have a tag that says I belong to an admin role. So when the subject accesses the object, the role that the subject is assigned is mapped to the role that the object contains, right? And then decides what the subject can actually do onto the object, right? So that's the role-based access control. So for example, if the subject is a human resources manager, let's say. So normally this human resource manager should be able to access all the human resources database, right? And perhaps even change it, because this person is almighty powerful in the realm of HR, human resources. So the role-based access control will definitely handle that part of it. But then think about this. Think about some place that you know that you have to go in where there are guards. And as you get into the building, they check your identity, they make you show your identification, and then you finally get to, let's say, your workspace or cubicle. And there's a PC there. And from that PC, let's say an HR manager can actually access everything, right? Because you're in a quasi-secure context that is the environment. Okay? But think about that same person hanging out, let's say, in a airport or some coffee kiosk. Tries to access the same thing, right? HR manager still accessing all the HR database in the corporation's database. Now, do you think that there should be some kind of a difference in actually doing the permissions for that HR person? Right? Just kind of think about that, right? Because if you are in a secure area, that's way different from being in an open area like the airport, using a Wi-Fi which may be compromised. Okay, and so you're not in a secure area. So if you're not in a secure area, regardless of what your role is, you should probably have less permission, because if someone attacks your system or they were able to see what you're doing, let's say in the airport or in the coffee kiosk, then they could do damage to your system. And that possibility is less if you are in a secure area like, let's say, your office. Okay, so but how do you handle this contextual thing? One, you're in the office. The other one, you're in the open area, like in the airport. How do you handle that part so that you say, if you're in the office, you can do everything. But if you're in the airport, you can only read stuff, regardless of who you are. And that's where ABAC comes in, right? So ABAC, A stands for attribute, right? So it's called attribute-based access control. And you should definitely think about incorporating this into your design. So the attribute-based access control is what they're saying is, what are the attributes? And if we're talking about contextual attributes, how can you tell the difference between someone accessing a database from the office, inside the office, and someone accessing the same database from outside the office? So you could have perhaps a geotagging, right? So those values are available. Perhaps a IP address, which one belongs to the company and the other one belongs, let's say, to the public internet. And based on that, in combination with their role, right? So okay, you're HR manager and you have a IP address that belongs to the office. Now the context is set, so you have access to everything. When that person moves out, let's say to the airport, you still have the same person with the same HR manager role, but now the IP address is different. So then you say that combination says that you can only have read access. Right? So for the authorization, RBAC and ABAC is usually used in a combination to go ahead and set the role that doesn't change, and also set the context, which changes the access level. Okay. And finally, accounting are logs, right? So this is the accountability accounting. So then you have to make sure that everything that people do, they're accountable for. And how do you keep people accountable? By keeping track, right? And if something goes wrong, you can always go back to the log and say, look, you, HR manager, did this thing, from a place where you weren't supposed to do it, and it's in the log. You're accountable for that if that causes a security issue. So you always want to make sure that the log is kept at the operating system, at the network, and also in your application. Okay, I think I'm pretty much complete on the controls. Are there any other questions relating to controls?
No questions.
Okay, sounds good. All right, then moving on. So there you go, how to protect it by putting in controls. And so your job then is to design in these controls, okay, to protect your system. So moving on to the next topic. Who is responsible? Okay. Now, there are many steps in creating a system, and designing is just one of the steps of several. Okay. So I want to quickly just go over what is this process and where do you fit in. Right? So let me go ahead and open that up. Okay, so I'm going to be explaining this using a concept of SDLC. In fact, let me go back to the Yeah, so sorry. So, right, that depends on which phase of the SDLC that you're in, okay? And of course, I'm going to explain what SDLC is. I just recall that I actually put that in a slide. All right, so SDLC, the original meaning of SDLC is software development life cycle. Okay, but many times people actually use software and change it to systems. Right, systems development lifecycle. Right, the original SDLC was, I think, coined by Carnegie Mellon University. I could be wrong, but people use these things interchangeably. So I'm going to be using in the vein of systems development lifecycle. In the systems development lifecycle, so this is, inception of an idea for a system, all the way to developing it, using it, and tossing it away at the end, right? At the end of the life cycle. So it's a life cycle, complete life cycle. And the steps are: 1, requirements; 2, design; 3, development; 4, quality assurance testing; 5, deployment; 6, operation; and 7, finally, end of life. Or decommissioning, okay? And let me very quickly go over what do you do. So you could probably see the flow, right? So someone conceives of an idea and says, usually a business owner says, I want to have this system, right, to do whatever, blank, okay? And then people like yourselves will design the system, right? And then that design gets passed over to, or passed down to coders or developers, and they actually create the thing that you've designed. And then that design and the creation of it must be tested. And the QA testing also includes security too, but then it gets deployed, and then hopefully it'll have a nice, healthy, long life in the operation. And when the thing is going to be replaced, usually the system goes to end of life. Right? So that's the entire, what's called the cradle to grave life cycle of a software, and this is SDLC. So then, obviously, the part that you belong to is here, right? So the design phase, okay? But you need to know what it is that you're not responsible for, okay? And what other people are responsible for. So there's actually security things to do in every single step here, right? So quickly, in requirements phase, somebody has to tell you what security requirements there are, but they're not going to tell you exactly how to do security, right? But they'll tell you what are their requirements. So we'll talk more about requirements, but this is not in the design phase, right? So requirements are something like, create for me a new system that handles credit card information that complies with the U.S. standard for handling sensitive information such as credit cards, right? So that will be the requirement. They're not telling you how to protect it, okay? But they're just telling you that, look, this is a requirement of the system, okay? Then you take that requirement for security, and then you design, okay, controls to actually effect that security requirement, right? So that your design handles that requirement for security. But the requirement has to be given to you, okay? But the thing is, when you design the thing, right, system, you have some option as an architect, right? You could say, I wonder if I can make this into a centralized system. I wonder if I can make this into a peer-to-peer system. I wonder if I could do this in a cloud system, et cetera, right? There are many, many forms of architectural design that you have options for. And by selecting any one of those things, your options, any one of those things will have its own set of weaknesses, right, that you must cover for. So take, for example, if it's a centralized system, you must handle the single point of failure, obviously, right? So if it's a distributed system, like peer-to-peer, you must account for all the controls the individual peers must have. What happens if you have a rogue peer, right? So it's harder to control that because there are many, many points where someone could become a peer in such a system. Okay? If you think about cloud system, I mean, that's what I was teaching all day today. With a cloud system, you got to handle the part about, wow, major part of our system is in a environment where I have no control over, right? So the cloud providers and cloud vendors are responsible, and I can't see through it. And I have to rely upon them, right? And that's a security concern, okay? So other than requirement, now you, at the number 2 stage, you've just added to possible vulnerabilities, okay, that a system could possibly have by choosing your design. So let's go on with that. So then that requirement and the design requirement goes down to the coder, and the developer develops, whatever you request them to do as you design. And developers can add additional weaknesses into the actual program by doing poor, insecure coding practices, by not putting in controls that they're supposed to, okay, by not understanding their tools well enough, because every single language, let it be Java, let it be C, let it be PHP, whatever, it has its own sets of vulnerabilities. So if the coders are not handling their tools well, they may go ahead and not cover for the weaknesses that they have in the tools that they're using, which are their languages or development environment. Okay, so that's a whole new set of vulnerabilities that may go in, right? So let me put it this way. If you don't define the security requirement, then you're just missing an entire requirement for security, right? So as a designer, if there's no security requirement, what is your responsibility for putting in design around the requirement that's not there, right? And the answer is none, okay? And you have to kind of confirm and say, hey, I think there must be some kind of requirement here that's missing. You have to inquire to whoever's responsible for coming up with the requirements. Because you're not, let's say, people will kind of look at it and say, look, you're doing some extra effort, right? You're doing something extra that I don't want you to do. You don't know, right? Maybe they forgot. Maybe they omitted on purpose. You have no idea, right? But you are responsible for any security issues that you may embed based on your decision for your architectural design, right? Developers are responsible for possible flaws that they may put into their system by their coding practices. QA testers, right, quality assurance testers, if they don't test security, right, and stop and make sure that all the things that are supposed to be there are not there or are there, or especially security controls. If security controls are designed into these areas, they better test them and make sure that they're functioning well. In deployment, the context, the software is now moving from a development environment into an actual operational environment. And, they're different, right? So the development environment is relatively clean. There are no other applications that are living with you, let's say, in an environment. Whereas in the actual situation, you may have all kinds of servers and other applications kind of side by side, lining up, to be served. And that may create vulnerabilities, right? Other servers and the environment changes may cause vulnerabilities. And look, while the thing is running, you may discover new vulnerabilities. You may have to patch the system. Anything can happen, right? So to make sure that the CIA of the system is continually maintained is the operations responsibility. And then at the end of life, you have to make sure that when you're getting rid of anything, you have to make sure that the critical information or the sensitive information is really destroyed, right? And for all those things, if you miss any one of those things, those are the causes for security vulnerabilities, security weaknesses in a system. So we have to then concentrate then, what are you really, really responsible for as a designer? And I hope this gives you some, responsibility matrix on who does what. Okay, and you have to hold these people accountable for their job. And the only person you really have to hold people accountable is make sure that the requirements folks gives you the proper requirements for security. Okay, so this is the responsibility section. Any questions on this?
We don't have any question. I think you're
Okay.
explaining very crystal clear.
All right, thank you for that. So then let's go ahead and move forward then. So in this case, now we know, what your responsibility is. That is, when you design, understand what type of vulnerabilities you are embedding by choosing those architectural designs. And you must take accountability for the requirements that are passed down to you from the requirements phase as to what type of security is requested. And when we talk about security, we're talking about controls. Okay? So then, how do you do that? Like, how do you know, how to handle the security requirements and what to do with it? And so here, we're going to be introducing some tools and references on how to do this. Okay? So I'll be covering mostly the requirements gathering stage, because you probably should understand what these requirements mean and how do you have to transfer that over into the controls within your design, and also in design stages, what are some tools that you will be using. So one, gathering security requirements. Okay, so for security requirements, just quickly now, what are some of the processes that they follow? So for security requirements, okay, basically, they'll come up with two things: functional requirement and non-functional requirement. Functional requirement is what the system must do, right? What it must do. Non-functional requirement is what the system must be like, right? So non-functional requirement is usually a system-wide requirement, something like a quality, performance. And security is usually in this non-functional requirement. But if someone tells you there must be a portal and there must be a strong authentication, then that would be a functional requirement, something like authentication. Sorry, I ran out of space. Okay, so understand that security requirements will come down to the design folks in forms of functional and non-functional requirements. Okay, so that should be good enough for that. And let's go ahead and move. So, for example, some of the examples are, I'm going to show you just a quick example for cloud control matrix. Okay, so cloud control matrix is a matrix of security things that must be done if you are to put a secure system in the cloud, right? Whether being infrastructure as a service, platform as a service, and perhaps even software as a service. And you also have compliance items such as payment card industry's data security standard, right? So let me just quickly show you what this cloud control matrix looks like. This is available. You'll get a link to this, but this is a set of controls that is the kind of security things that you have to consider when people are coming up with requirements for creating cloud systems. And it's produced by an organization called Cloud Security Alliance, and they have a bunch of resources around this. So for example, here it says domain control domains, application interface security, application security, and they tell you what these things are, right? And there are a bunch of these things, right? As you can see, okay, there are a whole bunch of control domains. Right now, you have identity and access management, audit tool access, right? And it'll tell you what it is: access to and use of audit tools, etc. Okay, so it's there for you as a reference. There are a bunch of stuff in here, so that if they are creating your, whoever's giving you requirements, creating a cloud security, they may give you, a bunch of these things as a design requirement. Okay. The next one is PCI DSS. So it's a compliance, right? So payment card industry requires that if you are anyone who handles credit card information as a, let's say, a payment or in processing, you must follow, and you will be audited, right, for the security as delineated in the PCI DSS, okay? And I believe I have a PCI DSS document here someplace. Let's see here. Oh, there it is right here. Okay. So something like a PCI DSS document is available for everyone. So if you happen to be creating something for PCI credit card information, there's a whole set of things, the requirements for the systems, and it's in this document. Okay, I'm kind of like, going through this, but it's there for you as a reference. Just understand, this is a compliance document. It tells the requirements. It won't necessarily tell you exactly how to implement them. Some of them might, but some of them won't. So you have to make a decision as a designer to put these, make sure that they're implemented in your design. All right, so let's go back to the browser. All right, so those are requirements, okay? So now, how do you build security into the design, right? Finally. Now we know that what it is that we are responsible for, and now we have to go through some tools, right? So these are some tools that I will quickly introduce to you. So these are use cases and misuse cases, trust boundaries, threat modeling, attack trees, attack libraries, and security design patterns. That last one is probably going to be a very good resource for you, but I'm going to keep that to the last, right? Always save the best to the last. So use cases. You've probably heard of terminology use cases, right? So, but I'm not sure if you ever heard of this thing called the misuse cases. Right? So the use cases is where you come up with all the features and functions that the particular system requires. Okay, so I pulled out, if you don't mind, a Wikipedia. And hang on here. I'm not able to see that picture, so let me go ahead and move it down so I can see the picture. And let me give you an example. So what does a use case look like? There it is. There's an example of the use case. All right, you basically come up with all the functions that are required, and you're downloading, writing down all the actors that are involved. So in this case, it's a food services use case. So you have the chef, you have the waiter, you have the client, you have the cashier, okay? And all the functions that the application must implement, okay? And obviously, this is going to be part of your design document. But this is a normal case, right? That's like, this is what you expect a system to do, okay? And you have to design in for that. But when we're talking about misuse cases, that's way different. So misuse cases, let's take the same example, right? Same food services, but notice that there's actually a brand new actor named crook, right? So these are all the ways that people can actually misuse your system, right? They'll steal the food, steal the wine, steal the client, steal the payment, okay? So the question is, that's not helpful, right, as is. What you need to do then is come up with priorities on which ones are more important based on the risk, right? How likely is it that this will occur, and what is the damage to the business? And you may not, right, as a designer, know that. So you may have to ask someone in the business to say, okay, all right, we'll try to put everything in, but which one's most important? Which one's second important, right? Ask those kind of questions. And then come up with controls that's going to mitigate that. And mitigation means we don't expect you to stop it fully, but we do expect your controls that you design in to reduce the risk. Perhaps to reduce the occurrence of or reduce the impact of such actions, right? So this is basically how you do it. But there is one problem with this. If you've never been a crook, how would you know to come up with all the things that crooks may know, right? Don't you think that's a problem? Okay. Now, can you ask a crook? Well, I don't know. I mean, do you know someone who could fit that role? Maybe so, right? But that's just one person's opinion too. Okay. So there's a better way to come up with all the possible things that a crook may have to do, right? And that's going to be your second line of tools. But before getting there, right, we'll get there, okay? But we need to talk about what's called trust boundaries, okay, trust boundaries. So these are flow diagram boundary identifies a security profile, okay? So that sounds kind of cryptic, but it's a pretty simple concept. So here we go. Flow diagram is a diagram of your application, right, or your system. And you show the flow of data through your application. So for example, you may have, let's say, a storage, right? So here's a storage, like a database, which let's say, a particular interface access. So here's the interface, right? Which interfaces with some process, okay? And right, so then this may have some accessibility by a person, right? So there's an interface again. Okay. So you say, where does the data go? So there's a data flow, right, like that. So you have the process, you have the interface, you have external storage, right? Very simple. Sorry, it's a very simple diagram. But in this case, one thing that's not here is something called the trust boundary. So the trust boundary is how much do how well do you trust these systems, and do you trust these systems in a different way depending upon that system. So let's say the interface, the user interface, let's say, comes from the internet. If that's the case, you draw a trust boundary. You say, that side, I have no idea. I don't trust it at all, right? It's the internet. You have no idea who's trying to access your system, right? Then you say, I'm responsible for this part, the process and the interface, let's say to the database. You say, I trust this thing, okay? And then you say, even though it's an internal system, database is handled by somebody else. There you go. And all these dotted lines could be just a line, like here, or a box, like here. You must, as a minimum, consider putting in security controls where the data flows across the boundary. So here, there, it crosses the boundary. Here, it crosses the boundary. Here, it crosses the boundary. And here, it crosses the boundary. Okay? You must, as a minimum, consider putting in controls in these areas. Okay? So if you draw your pictures out in the trust boundary, what you're saying is that I don't trust this, I trust this, I don't know about this, but I do trust some. Okay? You trust more than the public internet, but I trust less than what I know, which is my system, which contains system 1 and system 2. Right? So that's a minimum. So when this is mainly because bad things may come in, right? And good things may go out. You want to stop that, right? And same thing, bad things may come in, good things may go out, right? So those are some minimum things that could possibly happen. So you have to be able to identify a system in a flow diagram, in a design, as a minimum. But if you want to put protection around that, you can go ahead and do so. But what I'm saying here is the minimum requirement. Okay? Moving along. So that means flow diagram boundaries identifies a security profile. Security profile means how much do you trust that area. Okay? And you have to protect the area that you trust from the areas that you don't trust. And those are the controls. All right, security profile, right? Now, in order to do this, threat modeling is a very good way, a tool, to figure out then, for each of those areas that you identify, it says, it crosses a boundary, and I have to come up with all the different ways that people can attack here, and how do I protect them? And threat modeling is very good at working with flow diagram to identify all the possible threats and some suggestions for the type of controls that you can put into place. Right. So example is Stride. Stride is a methodology developed by Microsoft. It's been quite a while, but it's still considered relevant, right? But it's just one way of doing it. Okay. So with Stride, I actually have, I believe, you know what? Due to time, I think I'll just go and show you not the Microsoft presentation, but the Wikipedia, right? So basically, STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. So spoofing is violation of authenticity of source, right? Somebody's pretending to be somebody. Tampering is about the integrity, as I mentioned in CIA. Repudiation, we already talked about, right? It's where I say, hey, I didn't do it. Information disclosure is confidentiality. Denial of service is availability. Elevation of privilege is someone logging in, let's say, as a guest and using security flaws in the system to elevate their privilege to, let's say, admin, right? Hackers will always try to do this. So how do we use this thing? Well, let's get back to the flow diagram. You say to yourself, hey, is there anything related to STRIDE that could possibly go wrong here? So in that interface, you say, can somebody spoof? Can somebody tamper? Can someone repudiate? Can someone, do information disclosure, right? Can someone do denial of service? Can someone do elevation of privilege? Okay, so you apply STRIDE concept, right? It's like a mental process and say, each of the interfaces, can something bad happen related to STRIDE? Now, it's a very nice tool to, it may not be complete though, okay? Because I only considered these, 6 things. Right? So then, after you go through that process, when they say desired property, right? So spoofing, authenticity, tampering, integrity, etc. These are the type of controls that you have to put into place to gain authenticity, gain integrity, gain non-repudiation, etc. Right? So for example, information disclosure, you want to have desired property of confidentiality, and normally for confidentiality for systems, you use, encryption. Right? So that's a very good way of doing it. But then how do you know that the encryption manages confidentiality? Well, you may not know. Okay? Now, you may know that confidentiality encryption may help with confidentiality, but how do you know, what would you do for authorization? You know, because I just told you about RBAC and ABAC, right? So you have to put in those kind of access control. But there may come a time where you can't figure out what kind of controls that I need to put into place, what design things I need to put into place. And that's why I have additional resources for you, okay? But basically understand the process of figuring out where you have to consider for putting in extra control, and then what type of bad things may happen there, right? Threats. And depending on the threat, you have to put in the mitigation. And mitigation is basically gaining the desired property. And the desired property is going to be confidentiality, integrity, availability, authenticity of source, and non-repudiation. Right? I hope you see that as like an equation. Okay. All right, so let's go ahead and move forward. The next thing is an attack tree. So this is where you say, oh, I'm not a crook. Right? So if I'm not a crook, how do I know what type of thing the crooks will do? Well, you know what? Google search is a wonderful thing. And if you do attack tree search, for example, I have something called a virus attack. You say, I don't know how all these viruses or malware attack. And so if I don't know how they attack, I wouldn't know what kind of protection to put in. So you just say attack tree, right? So there it is. And people, right? You don't have to recreate the wheel. People have come up with all the different ways that the virus or malware could possibly attack, right? So there it is. It says virus affects a file, right? How? Virus runs an administrator. Virus runs a normal user. Well, if it's an administrator, how do they go about it? Virus exploits root hole. Virus run by admin, etc., etc. So do you see, right? So someone has actually come up from the perspective of a virus to show you all the different ways that the virus could attack. And it's not a point and say, I have to implement all that? I have to consider all that? And the answer is no. You don't have to consider all the possibilities. You consider the possibility that is most relevant to your application. Now, you may not know that, right? It says, my application, which one's most relevant? In that case, you actually do need to have some specialty, people with special knowledge about that, right? Some more deep knowledge about that. But this will get you started, for sure, okay? So that's an attack tree. Now, there's something similar called the attack libraries. Attack libraries are a list of all the possible threats against the vulnerability, right? That's a nice one, right? So there is an example called KPIC. And if you go to KPIC site, you say, all right, so let me go ahead and take a look at, let's say by, I don't know, let's say domain of attack, okay? And there it is. I'll say, okay, so supply chain. Let's say you're designing a supply chain systems. And they'll give you, they say, okay, so supply chain, modification during manufacturing, modification during distribution. There's like 439 of these things, right? So they'll just give you a list of, all the possible ways that people can actually attack the thing. All right, so I hope that gives you a pretty good tool sets to figure out all the locations and all the possible attacks that could possibly happen, depending upon the location of the boundary and also the type of industry or the type of application that you have to design for. Okay, and last but not least, I think this is going to really help you. But there are books available, and it's even titled "Security Patterns: Practices Designing Architectures." Isn't that great? Okay, I actually have this book. And it's available, but let's kind of take a look and see what are we talking about here. So here's the book, Security Patterns and Practice. Right? So this actually is just a chock full of actual design patterns that you can apply to your, your system. So if I were to take a quick look inside, okay, let's see here. Here we go. So I'm just going to kind of show you the good stuff. You'll probably get some ideas. Oh, look, right? Aren't these the kind of stuff that you want, right? These like little pictures here. Here we go. Let me see. There it is. Patterns. Nature of security patterns. Look, they all look like your thing, right? So these are all the design patterns depending upon the type of protection that you have to put in, okay? So for example, for access control, there's a pattern called the reference model, okay? So the reference model architecture, it's just one of the simple design pattern. And I'm coming very close to the end of my presentation. So let me just go ahead and quickly show you. Remember in access control, you have something called the object, okay? And you have something called the subject. The design pattern is to put in access control. So it goes like that. The design pattern here for your control is you put reference monitor. What does the reference monitor do? It uses a set of policies for access control. What's accessible, what's not accessible, to whom. And every time someone tries to access, you have to check and intermediate and say, nope, you cannot go, or yes, you can go. Right? It's pretty abstract. It's in the design document, but that's one of the models, right? And they're chock full of models in that book. And reference monitor is a pretty well worn out pattern, okay? But it works well because, for example, this is implemented in a firewall, for example, right? So somebody comes into the firewall and say, I want doing your job right. Next one is the Carnegie Mellon University survivability model. This model has been around for a long time, but survivability model looks at not just protecting the system, but how do you survive an attack, right? Surviving attack is a subset of protection. It's like you don't go down all the way. You kind of like hang in there until the attack subsides, and then you can go back into the normal operation. So that requirement is completely different from either having protection or not having protection. So check that out, right? And OWASP, if you're designing a web application, Open Web Application Security Project has many, many resources that's going to help you in design. All right, I think I've used up all my time. Thank you very much for your attention. Now, finally, do you have any questions at the end? I know it's 8 o'clock. Sorry to overrun it, but if you have any questions, I'll be happy to entertain them.
So far, I don't see any question, but I have a comment from Wang.
Okay.
It says, thank you very much for your presentation. It's very clear and detailed. Helped me understand the security model better. Indeed. I second that.
Well, thank you very much. I really appreciate that. At some level, it may seem simplistic, but these are the things that we have to have a common understanding about. I know that this will only get you started in your effort, and I know that you have additional resources, right, that you're going to be providing to them?
Yes, absolutely.
Okay, wonderful.
Any question from anyone? Please type in the question box. I think, as Wang said, your presentation was very clear and detailed. I think nobody has any question.
Okay, I'll take that as a sign that that you've learned something new. And once again, thank you very much for your attention, and thank you very much for inviting me to give you this presentation.
And thank you so much for your wonderful presentation, Terumi.
Okay,
And
anytime.
yeah, I totally enjoyed your presentation, and I'm sure our students enjoyed it too. Thank you so much.
Okay, you're welcome. Good luck.
Good evening, everyone. Thank you very much.